So the small intestine ends up dumping into the large intestine at the ileocecal valve. And by the time the chyme gets to the ileocecal valve, most of the absorption has happened. Most of the water has been absorbed. Most of the nutrients have been absorbed. Most of the digestion has already happened. Uh, and really, what's left is um, some wet, undigestible stuff for the most part. Um, so the large intestine's job is basically to absorb the last little bit of water. I mean, there's a few other minor things that it does, but it basically forms feces. It forms poop. Um, Now, when we look at it anatomically, you see basically three things. There are these bands of longitudinal smooth muscle that run up either side of it. There might be three of them, maybe two. Usually there's three. And they're called the tenai coli. And what it ends up doing is it ends up pulling the circular bands into these pockets called the haustra. It's kind of like smocking. And then hanging on the outside are like looking like candle wax are fat-filled pouches of the peritoneum called the epiploic appendages. Nobody really knows what they're for. Excuse me. So it's divided into different bits. From the cecum moving up, it's the ascending colon. Uh, on the other side, on the left side, it's the descending colon, and both of these are found retroperitoneally. The transverse colon and the sigmoid colon um, are not retroperitoneal. They're hung by mesenteries, which are actually called mesocolon because it hangs the colon. So it ends up looking like this. Um, right. So the jejunum and the mesenteries end up here. The greater omentum, the transverse mesocolon, does the transverse colon, the transverse sigmoid colon is here. If we look at it in cross section, uh, it's actually very interesting. What we get here is a continuous line here that is the greater omentum, the lesser omentum around the liver, the parietal peritoneum around the body wall, the mesentery around the intestines, like this. This all ends up terminating. Well, actually, we missed this one. So, ileocecal valve comes in here. This area is called the cecum. It's very large. Coming off this cecum is the appendix, the vermiform appendix. This is filled with reticular connective tissue, so it's all lymphatic tissue here. The haustra are these, the tenai coli are these, the epiploic appendages are these. This is the ascending colon here. It takes a turn to the left here behind the liver, so we call that the hepatic flexure. This is the transverse colon. Then it takes a 90-degree turn behind the spleen, so we call that the splenic flexure. This is the descending colon, and then moving back towards the midline is this S shape or sigma shaped part of the colon called the sigmoid colon. Now, on the center line straight up and down, we have the rectum, which is found in the cavity, and then embedded in the pelvic floor is anal canal, and there are sphincters to the anal canal. So when we look at the rectum and anus, these become different than the there's no haustra, there's no teni coli, etc. So the rectum end up having little flaps called valves. And they're here. They're called the rectal valves. And basically what they allow you to do is pass gas without defecating, so without soiling yourself. They hold the feces in place while you fart. There are veins called hemorrhoidal veins that drain the area. You'll notice that that the walls of the anus are thrown into folds vertically so that the anus can basically pucker closed or expand to allow the passage of feces. We call this the anal canal, and we call these the anal columns. The outer part of the anus is here, and we call it the pectinate line, is kind of between where the anal columns are and the outer side of the anus are. There are a whole bunch of skeletal muscles that surround the anus and the anal canal. There's a muscle that helps you lift the anus called the levator ani muscle. It's part of the pelvic diaphragm. There are muscles that hold the anus closed so that feces are not released accidentally. There is an internal anal sphincter that's primarily made up of smooth muscle, and it holds the anus closed the majority of the time. When there are feces in the anal canal and you have that urge to defecate, then that internal sphincter relaxes and the anus opens. You control it from there with these external anal sphincter muscles, which are voluntary skeletal muscles. They take quite a bit of energy, actually, and basically that's how you hold your poop until you can release it. So when we look at the mucosa, it's a simple columnar epithelium until we get down to the anal canal. Then it becomes stratified squamous, because that's the point where feces can actually start to do damage. There's lots of goblet cells and there's lots of crypts. So what we want to be able to do is grease these feces up quite a bit with mucus to help them pass. And it's completely surrounded by veins, which, if they get inflamed, are called hemorrhoids. The environment of the large intestine is that there is flora. There are bacteria that live in there, and they're very important to us. And they either get in from the small intestine end, or they enter through the anus, and they colonize. And what they do is they break down any indigestible carbohydrates. Usually it's cellulose. And they make the B vitamins and vitamin K for us. So basically, we provide them a place to live, and we provide food for them, so they get room and board in us, and they pay their rent in vitamins. Now, if we have these indigestible carbohydrates, what'll happen is that if there's too much of it, it ends up becoming gas. This is why beans cause gas, because there's a fair amount of cellulose in the beans, indigestible carbohydrates, indigestible to us, quite digestible to the bacteria that live there. We use the large intestine to absorb those vitamins. We take the last little bit of water and the last electrolytes that haven't been reabsorbed. But again, 90% of that is done in the small intestine. So this is just finishing it off. The major function is to make feces and move them out of the body. There are segmenting movements that happen in the large intestine, basically churning and slowly moving towards the anus. So it moves things up from the cecum across up the ascending colon, across the transverse colon, and down the descending colon over the course of the day. And there's segmental movements like we've talked about before. When you eat, however, there's a reflex. When there's food in your stomach, you get a peristalsis, which is called a mass movement. And it basically takes all of this fecal matter and by peristalsis pushes it down into the rectum. And it happens in a powerful peristalsis. And it happens after you eat 3 or 4 times a day. And that's why you don't feel like you need a bowel movement until you've had your morning cup of coffee, because coffee will trigger that gastrocolic reflex and cause this mass movement and move that fecal material down into the rectum and make you want to defecate. So when the feces are forced into the rectum stretches, right? And then there's a spinal reflex that causes that to happen. There's contraction in the sigmoid colon, and then relaxation in the internal anal sphincter. And then you activate the external anal sphincter consciously to hold it until you get to the bathroom, to the place where you want to actually defecate. If you don't defecate, then what happens is eventually, in a few minutes, what will happen is the walls of the rectum will adapt. It will stop initiating the defecation reflex. The internal anal sphincter will adapt and return to being closed, and you will lose that urge to defecate until the next mass movement causes even further distension. And that's one of the problems with constipation, is that if you don't heed the urge, then you need that much more pressure to consciously to make it happen again.